Hello everyone, welcome back to my channel Study With Me. Today I'm going to talk about Chemistry Standard Level Paper 2 May 2023 Time Zone 2. If you find this video is helpful, don't forget to subscribe and let your friends know so you can study together. And let's get started. Analytical and spectroscopic techniques enable chemists to identify and determine structures of compound. A known compound X comprising of only carbon, hydrogen, and oxygen. Carbon is 48.6%, and then oxygen is 43.2, so hydrogen will be 8.2, so total is 100%. So we need to find the mole of carbon first. So 48.01 divided by its molar mass, which is 4.05 mole, and for oxygen would be 43.2 divided by 16 is 2.7, and for hydrogen is 8.2 divided by 1.01, it's 8.12. Okay, to know the unknown or the empirical formula for this unknown organic compound, we cannot use this decimal point, so we divide with the smallest number. So this will be 1 divided by 2.7, you will get 1.5, and then divided by 2.7 you will get 3. Again is decimal, so we just multiply all by 2. So C will be 3, H will be 6, okay, 3 times 2, and then O will be 2. And for this one, I cannot answer because the picture is removed for copyright reasons, but we need the answer to continue for the next question. So after seeing the mark scheme, the MZ74 is C3H6O2 plus, and then 45 either COOH plus or C2H5O. C3H6O2, the molar mass is 74. Usually when you see the picture right here, that should be available if when you have an exam, that would be the molar mass of the actual compound, usually the highest number. So you have 45 and then 74, and sometimes you get 15 is CH3. So 74 is the actual compound. So C3H6O2 is the actual compound. And how do we know the molecular formula? So simply just copy them, that would be the answer. So this is the infrared spectrum. So as you can see, the peak is at 3000 and at 1700 something. So this will be OH minus if you refer to the data booklet. So it's OH, and then this will be C double bond O. How do I know is OH? As we know here, it has COOH, so therefore there is hydroxyl group, and this one is carboxylic acid. It's very obvious. So carboxylic acid contains carbonyl group C double bond O, so it's around 1700 to 1750, and this one until 3000 when you refer to the data booklet section 26. So the answer is OH and C double bond O. Next, nitrogen 4 oxide is a brown gas found in photochemical smoke and has a pollutant causing acid deposition. At 100 degrees Celsius, Kc for this reaction is 0.0665. Outline what this indicates about the extent of this reaction. Okay, when Kc smaller than 1, the reaction is hardly proceeds at all towards the reactant. But if K bigger than 1, the reaction proceeds almost all towards reactant. So in this case, Kc is smaller than 1. Reaction hardly proceed, or it could be reverse reaction, or reactants, concentration of reactant bigger than product, because the reaction is hardly proceed. Calculate the value of Kc at 100 degrees Celsius for the equilibrium. So N2O4 produce 2N2, 2NO2. So as you can see, this is reverse. So Kc when it's reverse is to the power -1. 1.5 equation, half of the coefficient, it will be square root. When it's double the coefficient, that would be squared. So Kc will be Kc to the power -1. So 1 divided by 0.0665, this number, and you will get 50. Okay, calculate the standard enthalpy change in kilojoule per mole for the reaction. So to calculate standard enthalpy change, it will be product minus reactant. Okay, product is 2NO2. So because the coefficient is 2 times 33.18 minus 9.16, you will get 57.20 kilojoule per mole. So the structure N2O4, it has a double bond and then single bond as well. So N and this O, and O. So this will be double bond, the NO bond length in N2O2 are all based on equal NO bond length. 1.19 times 10 to the power -10 m suggests what the bond lengths indicate about the structure of N2O4. As you can see that it presents double bond and single bond, it means it has resonance structure where often involve the localized electron. This implies that the bonding between nitrogen and oxygen atom is equivalent throughout the molecule. So that's why all present here. So it's because it has resonance structure. Predict the O and N bond angle in N2O4. So if we write it back here, this will be trigonal planar. The angle is 120 degrees. Acid deposition is formed when nitrogen oxides dissolve in water. Write an equation for nitrogen 4 oxide reacting with water to produce 2 acids. So that would be 2NO2 gas. When it react or dissolve in water, will produce HNO2 and HNO3. Electrolysis and Winkler titrations are both applications of redox reaction. An electrolytic cell was set up using inert electrode and molten magnesium chloride MgCl2. Okay, for electrolysis. So the plus, that would be anode. Okay, so panic, right? So positive anode, negative cathode, and always cath, red, and ox. So anode oxidation, lose electron, cathode reduction gains electron. Okay, So we have MgCl2 and it dissolves in water. So the ion will be Mg2 plus and Cl minus, and the ions from H2O, that would be H plus and OH minus. So OH minus will be here and Cl minus will be here, Mg2 plus will be here, and H plus will be here. Okay, the flow of the electron will be from here. Okay, so to here. All right, identify the product formed at the cathode. So we have cathode, so we have Mg right here, so it will be magnesium metal, because cathode is reduction. Here I already annotate the diagram to show the movement of the electrons. I already annotated as well. Graphite rods are sometimes used as inert electrodes. Describe the structure of graphite and explain why graphite conducts electricity. Graphite, it contains layer of carbon atoms in the giant structure. It conducts electricity as it has delocalized electron that flows along layers. Okay, graphite consists of layers of carbon arranged in a hexagonal lattice structure. It has a joint structure. Each carbon atom is bonded to 3 others, forming strong covalent bond within layers. Within each layer of graphite, 1 electron from each carbon atom is delocalized. So this facilitates the flow of electric current, allowing to conduct electricity effectively. Okay, Winkler titration. Winkler titration can be used to determine the biochemical oxygen demand BOD of a water sample. 100 centimeter cube of a water sample was tested using a Winkler titration. 36 centimeter cube of 0.005 molar sodium thiosulfate solution required to reach the endpoint. Determine the concentration in mole decimeter cube of oxygen dissolved in the water sample. The Winkler method is used to determine concentration dissolved oxygen in water. Oxygen first oxidize the soluble Mn2 plus ion to form insoluble manganese hydroxide. Then manganese hydroxide will react with I minus, okay, this, forming I2. The form I2 reacts with excess I3 minus. This I3 minus ion then is titrated with thiosulfate. Okay, so getting the volume or measuring the volume of thiosulfate will help to calculate dissolved oxygen. All right, so volume of water is 100 centimeter cube, which is 0.15 decimeter cube, and volume of sulfate is 36 centimeter cube, which is 0.06 decimeter cube, and the concentration is 0.005. Okay, so we start with the mole of thiosulfate. Okay, so that would be 0.05 times 0.036. You will get 1.8 times 10 to the power negative 4. And for I2, okay, so we go back up. So after this thiosulfate, we go to I2. And as you can see, is for I2 is half of the thiosulfate, so that would be half times 1.8 times 10 to the power negative 4, which is 0.0009. And then now we go to the Mn2 plus. Okay, so it has the same coefficient, so Mn2 plus will be 0.0009. And now we go to the manganese hydroxide, so NMN2 plus, the same with MnOH2. They have the same coefficient as well. Okay, right here with Mn2 plus. Okay, this and then this, so that would be 0.0009 mole as well. And we reach to the oxygen. Okay, these two, that would be half of MnOH2. So an oxygen will be half of 0.0009. You will get 0.00045. Okay, so for the concentration of oxygen, that would be 4.5 times 10 to the power negative 5 divided by volume, which is 0.15, and you will get 3 times 10 to the power negative 4 mole decimeter cube. Outline how the BOD of the water sample could be determined. You can do titration, titrate it. So you measure dissolved oxygen in water sample, so you will get difference between two values that would represent BOD. How? To determine BOD of a water sample, dissolved oxygen first is measured right after collection. So when the sample is collected, dissolved oxygen is directly measured by doing titration, and then it is stored for 5 days. This to allow microorganisms in the sample to consume organic matter. And then DO is measured again after 5 days of storage. Then the difference in DO is calculated. The difference represent BOD. So suggest what a low BOD value indicates about a water sample. It means there is not a lot of oxygen consumed by the microorganisms or of water pollution. So low levels of oxygen consuming of water pollution. So low DO difference, low BOD. The periodic table provides information about electron configuration and physical and chemical properties of elements. Bismuth has atomic number 83. Deduce 2 pieces of information about the electron configuration of bismuth from its position on the periodic table. Bi has 5 valence electron as it is in group 15. So Bi is right here. So the valence electron is 5. And for the atomic number is 83, of course it will reach D and F orbitals. And you know this is period 2, so 2s1, 2s2, and we directly jump into P because D is right here. So 2p3, 4, 5, 6, 7, 8. So the same with this as well. So that would be 6x1, 6x2, and then 6d1, and we jump here 6p1, 6p2, and 6p3. So it's unpaired electron because only 3 spin that would be in each orbital of p, so it's unpaired. So we can answer right here. Bi or bismuth has 5 valence this electron as it is in group 15 and occupied D or F orbitals. You can choose two of these three, or it has unpaired electron. Okay, outline why aluminum is malleable. Malleable, it means it's easy to bend or hammer it into shapes, but layers of cations slide one over another even without disrupting bonding or changing the shape, does not disrupt bonding. So even though you bend or hammer into a shape, the bond will not be disrupted, because you know metal has a regular structure. So example like this, okay, it means that the different layer, this layer can slide one over another, so it will not disrupt the bonding. So they are not as fixed as you might thought. It's just rigid, so the layers cannot be slide over one another. In this case, metal will not be malleable. 11.98 gram block of pure aluminum was heated. Calculate the heat energy absorbed. So that would be mc delta T. Mass is 11.98 times C, 0.902 times 40 minus 18 is delta T here. So you will get 288.38 joule. Argon has three naturally occurring isotopes: 38Ar, 36Ar, 38Ar, and 40Ar. Identify the technique used to determine the relative proportion of the isotope for argon. It's only one technique. It's called mass spectrometry, or you can also call mass spectroscopy. Okay, this technique is used to identify or characterize chemical compounds based on the mass to charge ratio of their ion. The isotopic composition of a sample of argon is 0.34%, so that would be 0.0034 divided by 100, and the other numbers. So calculate the relative atomic mass. That would be 0.0034 times 36 plus 0.0006 times 38, this divided by 100, this also divided by 100, times 40, plus 0.996 times 40. You will get 39.99. State the full electron configuration of the cobalt 2 ion. Okay, if it's cobalt only, the number is 27. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7, and for cobalt 2 plus, okay, so because 2 plus, so 2 electron will be removed, that would be this. So if I write in the short notation, so I use Ar, noble gas, that would be 3d7. This Ar will represent this 18. Methanoic acid is monoprotic weak acid. The concentration of methanoic acid was found by titration is 0.2 molar standard solution of sodium hydroxide. So it is titrated using an NaOH with 0.2 molar using an indicator to determine the endpoint. Calculate the pH of the sodium hydroxide solution. So OH minus will be 0.2 molar. So to calculate pH, we need to calculate pOH first because the concentration of OH minus is known. So that would be negative log concentration of OH minus, which is 0.2, and you get 0.699. So pH will be 14 minus 0.699 because pH plus pOH is 14, so 13.301. Write an equation for the reaction of methanoic acid with sodium hydroxide. Methanoic acid is HCOOH aqueous with sodium hydroxide. If you find this is challenging for you to define the product, so you can always check their ion. So HCOOH is acid, so it produces H plus, and HCOO minus, negative positive. So Na plus, and then OH minus. So positive ion will be with negative ion. So HCOONA is negative and positive cancel out, and aqueous plus H2O liquid. 22.5 centimeter cube of NaOH neutralize 25 centimeter cube of methanoic acid. Determine the concentration of the methanoic acid. So the concentration of acid will be the volume of NaOH divided by volume of methanoic acid that is used time concentration of NaOH from this. Okay, so mole per decimeter cube, so you will get 0.18 mole per decimeter cube. Suggest an experimental method that could be used to determine the rate of reaction. When determining the rate of reaction, we always measure the change of mass, or as this is 2, so you can choose 2, mass of pressure or volume of gas CO2 produced, because it produced CO2 right here, and electrical conductivity. The sulfuric acid is a catalyst in this reaction. Explain how a catalyst increases the reaction rate. Catalyst provides alternative reaction pathway and lower deactivation energy. Methanoic acid can react with ethanol to produce ester. Okay, when alcohol react with carboxylic acid in the presence of concentrated sulfuric acid and heat, it will produce ester and water. Okay, so how methanoic acid produce ester when it reacts with ethanol? So alcohol, ethanol, so this will be, okay, let me just make it easier for you to see for the ethanol. Okay, react with methanoic acid. Alright, so when they react, so this O will bond into C. Okay, so H will leave this structure, and OH also will leave this structure, so it will form water, H and OH. So you can just combine them, CH2, so O, and then this bond with C, and then with O, and we have H right here. Okay, so that would be the structure. CH3, CH2, and CO, C, double bond O, and H. So the name would be alkyl alkanoate. Okay, alkyl. So we have C2 here, so that would be ethyl alkanoate. So we have COH, so only one C, so that would be methanoate. Write the equation for the complete combustion of ethanol. So ethanol CH3CH2OH react with oxygen, produce, if it's complete, CO2, if it's complete, incomplete is CO, plus 3H2O gas. So this will be 3 and 2 and 3. Determine the enthalpy change for the combustion ethanol. You will refer to this data of section 11. Okay, bond enthalpies. So let's breaking it down first. So I always like to break it down into the lowest structure, so I will not make any mistake. Plus 3 HOH. So as we can see, we have 1 CC here plus 5 CH plus 3 O double bond O. So CO, there are 2 times 2, so it will be 4. That's why I always like to breaking it down into this structure, so it will be easier or clear for me the bond that is present, the bonds that are present in the structure. So OH, so it's 2 times 3, so it will be 6 OH. So if you refer to the data booklet, you get this 346 plus 5 times 414 plus 3 times 498. Okay, and then 4 times 804 plus 6 times 463. You will get 4,731, and here 5,994. So delta H will be bond forming. Here is bond forming minus bond breaking. So 4,731 minus 5,994, you will get negative 1,263 kilojoule per mole. Bromine also reacts with butene. Identify the type of reaction. Okay, it's electrophilic addition, because bromine is acting as the electrophile. Electrophilic addition. Okay, electrophile is a reagent that accepts pair of electrons to form covalent bond, and butene is acting as a nucleophile because it has pi bond. It has double bond. So electrophile will attack nucleophile butene attacks electrophile, causing double bond breaks. So electrophile is partially positive neutral that will breaks the double bond. Predict the structural formula of the reaction product. Okay, so butene CH2 CH3, and then CH double bond CH, and CH3. So this is but2-ene, react with Br2. So this will be break, producing CH3, CHBr, CHBr, and CH3. Draw the structure of a section of a polymer formed from 3 monomers of but2-ene. Okay, so but2-ene structure, it's CH3, CH, double bond CH, and CH3. So for polymer, that would be CH, I start from here, and CH3, this, and the other one CH, CH, and CH3. Then you can just repeat it 3 times. So that would be CH again, CH3, CH3, and H, this. Okay, so it's repeated 3 times. All right, so that's all for the chemistry paper 2 standard level May 2023 time zone 2 explanation. I hope this video is helpful for you for the exam preparation and also doing a revision. If you find this video is helpful, don't forget to subscribe and let your friends know about my channel as well, so you guys can study together. And bye for now.